Good morning to all. Welcome back to our class. So, in the last class, we have seen regarding invertible matrices, right? Invertible matrix we have seen. Invertible matrices, and there is a theorem in that also we have seen. Now, let us see how to find the inverse of a given matrix. Let us see how to find the inverse of a given matrix. Inverse of a given matrix. Actually, invertible matrix definition, as per the definition, what we know, AB into BA equals A into B equal to B into A equals to I. If it happens, then we can say that B is the inverse of A. A is the inverse of B. Right? So, inverse of B is inverse of A. B is inverse of A. B is inverse of A. For example, there is one matrix 1, 2, 3, 4. How to find the inverse for this matrix? How to find the inverse for this matrix means this matrix, this is one matrix, we have to multiply with one matrix, we get 1, 0, 0. I means 1, 0, 0, identity matrix, right? With which matrix we have to multiply this matrix, with which matrix we have to multiply this matrix to get this one. With which matrix we have to multiply this matrix to get this one. That matrix is called inverse for us. Inverse for us. With which number we have to multiply 5 to get the answer 1 with 1 by 5. And this is inverse for this is inverse for this. What is multiplicative inverse of 5? 1 by 5. 5 cancel. Same like that in matrix language. With which matrix, with which number, with which matrix we have to multiply this matrix, multiply with this number to get the answer I, to get the answer 1. Here identity matrix, here 1. That is matrix language. This is real numbers, right? So there is some procedure to find out this inverse. To find the inverse of a given matrix, there is some procedure. First of all, let us learn that procedure. I mean to say that there are some rules. There are some rules. First of all, let us learn those rules. Then I will start the problem. Then you will understand clearly. Okay? First of all, let us see those rules. After completion, how to apply the rules, where we have to apply the rules, how to apply the rules, in what way we can apply the rules. We are going to learn the rules. Okay? So concentrate on the rules, how to apply. Oh, this is the method, this is the method. So in this way we can apply, in this way we can apply, in this way we can apply. Right? Just you see the rules and let us learn the rules. Once after completion of explaining the rules, then I will tell the problem. Once after telling the problem, you can understand. How to apply the rules, you will understand. Right? Now we are going to see the rules. What are the rules? Elementary operation, transformation of a matrix. Elementary operation. In brackets, transformation of a matrix. Elementary operation, brackets, in brackets, transformation of a matrix. Okay. This one, sir, how they ask the question in the exam? They ask the question in a simple way that find the inverse of the matrix. Find the inverse of matrix by using elementary operation. That's it. In this elementary operation, there are two types: row operation, column operation. Just listen, just listen. Row operation, column operation. Two types are there. Chances are there to ask anyone. In general, they don't mention. Just they ask you to solve the problem by using elementary operation. Okay? Either row operation we can do or column operation we can do. If they specify in the question that we have to apply row operation, then we have to apply row operation only. Right? So in general, how they ask the question? Find the inverse of this matrix by using elementary operation. That's it. By using elementary operation. Right? Now let us see those operations, how to apply, what are the rules. Operations itself, rules. What are those? What is the first rule? First rule, what is the first rule? The interchange of any two rows, otherwise any two columns. Symbolically, the interchange of ith row and jth row is denoted by Ri to Rj, and interchange of ith and jth column is denoted by Ci and Cj. Means here we can interchange any rows or any columns. As per this rule, we can interchange any two rows or any two columns. For example, this is one matrix: 1, 3, 5, 7, 6, 2, 9, 8, 0. In the beginning class only I told, in the first class only I told, very important, which is row, which is column, which is row, which is column. 3 rows are there, 3 columns are there. These are the rows, these are the columns. Okay? These are the rows, these are the columns. This is the first row, this is the second row, this is the third. This is the first column, second column, third. Clear? What is first property, first rule says? What is the first property, first rule? We can interchange any row with another. We can interchange any row with another. Means, sir, I want to interchange R1 and R3. Yeah, you can. How to write that one? Changing R1 to R, no, not necessary. Simple. R1 and R3 I want to interchange. That's it. This is the representation of change of first row and third. Second row same as it is, 7, 6, 2. First row and third row we are going to interchange. Third row becomes first row. First row becomes third. Sir, why to change? These are the rules we are learning to solve, to find the inverse of the given matrix. Why to change this? There we will get. While solving the problem, while finding the inverse of a given matrix, we will come to know. Okay? There we will come to know. So, this is correct. Next, how to change the column? Same like this. I want to change second column and third column. How to write? This is the way to write. I want to change second column and third column. This is the way to write. Right. First column as it is 1, 7, 9. Second and third column interchange. So third column becomes a second column. Third column becomes a second column. Third column becomes a second column. Second column becomes third column. That's it. This is the first property. Just remember, first rule, first transformation, first elementary operation, first operation, we can say. Okay? We can interchange any two rows or any two columns. Right? This is first. Let us see what is second. This is the way of representing. This is the way of representing. Second, the multiplication of the elements of any row or column by a non-zero number. Symbolically, the multiplication of each element of ith row by k is denoted by something something. Corresponding column operation is denoted by C1 something something. Right. Suppose the second rule says that you can multiply any row with any number. You can multiply any column with any number. Understood? No. Let us see example. Let us see example. Same matrix. I will keep this matrix as it is. 1, 2, 3, 5, 7, 6, 0, 1, 0, 1. Number not 9. Okay. I want to multiply first column with 3. I want to multiply first column with the number 3. Okay. How to write that one? In working, not necessary. We are multiplying first column with 3, not necessary. Symbolically, first column we are changing. How we are changing? Like this. Over. Right? So how the matrix becomes? First column we are multiplying with 3. First column, second column as it is, third column as it is. First column we are changing like 3 into first column. What are the elements in first column? List. Multiply with 3. 3 ones are 3, 3 5s are 15, 3 zeros are 0. That's it. That's it. Okay. Same like the row operation also. You want to multiply, not adding, not subtraction. Multiplication only possible, not addition, not subtraction. You want to change the second row like this. You want to change the second row like this. You can change like this. Second row means first row will be as it is, third row will be as it is. Second row we are changing. How you are changing? You are multiplying the elements which are in second row with 2. You are multiplying the elements which are in second row, multiplying with 2. Okay? So 2 5s are 10, 2 7s are 14, 2 6s are 12. This is the way of representing. You want to change R1, you want to change R1. How you want to change? You want to multiply with 4 by 5. Yes, this is the way of representation. Okay? So this is one operation, one elementary operation. One rule. Next one. What is there? Next one is working is okay. The addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero number. Symbolically, the addition to the elements of ith row, the corresponding elements of jth row multiplied by k is denoted by something, something, something. What this property says that, again if I, okay, 1, 2, 3, 5, 7, 6, 2, 9, 8. This is one matrix. What I want to do, I want to change R1. I want to change R1. How I want to change R1 means R1 plus 2 R3. I want to change R1. How I want to change? Like R1 plus 2 R3. 2 into R3. R3 means 3. Multiply with 2. Then add that. So we are not discussing anything second row. Second row will be as it is. Second row will be as it 90s. We are changing first row. We are changing first row means third row also as it is. What we are changing? We are changing first row. We are taking the help of third row. We are taking the help of third. We are changing first row. So third row will be as it is. What is third row? 298. 298 will be as it is. We are changing first row. How we are changing? First row plus 2 R3. First row. What is first row? R1. What are the elements in R1? 1, 2, 3. 1, 2. What are the elements in R3? R3 elements. R3. 298. 298. We want 2 R3. 2 into R3, 2 into 2, 4, 2 into 9, 18, 2 into 8, 16. Okay, now, first we have to write R3, then you can understand easily. First we have to write R3. What is R3? 298. 298. What we want? 2 R3 we want. So multiply. 2 2s are 4. 2 9s are 18, 2 8s are 16. Okay. What is the addition? R1 plus 2 R2. 1 plus 4 5, 2 plus 18 20, 3 plus 16. Where we have to write? In first row. Why we have to write? We are changing first row. That's why we have to write these values in place of first row. So 5 and 20. This is also one type of operation. That is also one type of operation. Sir, compulsory addition only? No, you can subtract also. Let us see one more example. I want to change R2. Like I want to change R2. Like R2 minus R1. We are changing R2. Second row we are changing. First row as it is. Third row as it is. Third row as it is. We are changing second row. How? R2 minus R2. What are the elements in R2? 5, 7, 6. R1. What are the elements in R1? 1, 2, 3. Subtraction. Right here. Okay. One more example. Two more examples. Why? Because we have seen only row operations. One more two example, then I will come to R. Same method is same. So I am going to change R3. Third one I am changing. How I am changing? 3 R3 minus 2 R1. 3 R3 minus 2 R3. Third row we are changing. First row as it is, second row as it is. First row as it is, second row as it is. I am telling all examples for this matrix only. Remember that one. I am telling all examples for this matrix only. So R3 we are changing. R3, what is R3? 298. R3, 298. R1, what is R1? 1, 2, 3. 1, 2, 3. We don't want R3. We want 3 R3. 3 R3. 3 2s are 6. 3 9s are 27. 3 8s are 24. R1. We don't want R1. We want 2 R1. 2 1s are 2, 2 2s are 4, 2 3s are 6. What we have to do? We have to subtract. If you subtract 24 minus 6, 18, 27 minus 4, 23, 6 minus 4. Okay. Last example with respect to column. I want to change same things. I want to change first column. How you want to change first column? First column plus 2 into 6. First column we are changing. First column 1 by 2, 1 by 2. Second column, what are the dimensions we have? 2, 7. 2, 7. We don't want C2, we want 2 C2. 2 2 7, 4, 2 7 7, 14, 2 9 7. What we are doing? Adding 29. So where we have to place our first column? 5 into. That's it. That's it. Clear? So this is third operation. With this operation, we can solve the problems easily. Okay? But what I am doing here, just if I tell these, you cannot understand anything. You cannot understand anything. As per this method, I have to teach 3 questions. First question I teach very slowly. Second and third questions a bit I increase the speed. Then fourth question onwards, automatically you only will solve. But the thing is, you have to listen the first 3 questions with lot of patience. Sir, we did not understand anything. We did not understand the first question, anything, no problem. Listen the second question very clearly. 200% assurance I can give. You will understand very clearly. No doubt. Only thing is, you should not lose the patience. You should not lose the patience. Without losing patience, if you listen, definitely you can understand. Here, elementary operation, few operations we did for rows, few operations we did for column operation. In the examination, sometimes, in very less cases, they ask, find the inverse of the matrix. Find the inverse of 2, 3, 5, 7 by using row operation. By using elementary row operation. Find the inverse of 2, 3, 5, 7 by using elementary column operation. Okay? Chances are there, very less chances are there to ask like that. In general, how they ask the question? Find the inverse of the matrix 2, 3, 5, 7 by using elementary operation. If they ask this in the question, listen very carefully. If they ask this in the question, then you can follow either row operation or column operation. If they ask this in the question, then you can follow either this operation or this operation. That is your issue. If they ask this one, then you have to follow row operation only. If they ask this one, then you have to follow only column operation. In the question, they did not mention whether by using row operation or column operation. At that time, your wish, whichever the operation is comfortable to you, you can use that one. Right? Very clear, I think? Okay. Now, let us see the question. The question is, here the question is using elementary transformation. That's it. They did not mention by using row operation, by using column operation. By using elementary transformations. Find the inverse of each of the following matrices if it exists. Okay, if it exists. What I am doing here, totally 15 questions are there. I am not going to solve all those 15 questions because all are same method. I will explain the questions. 3 questions for row operation, 3 questions for column operation. Remaining questions you do homework. Remaining questions you do, right? So here one more thing I have to tell you. Whenever you want to follow row operation, row transformation, whenever you want to follow row operation, then you have to take in the beginning, you have to write A equal to IA. A equal to IA. What is this A equal to IA? For example, A is any given matrix. A is any given matrix. 1, 2, 3. What is I? 1, 0, 0. What is A? 1, 2, 3, 4. How it is looking means 2 ones are, 3 ones are. Identity matrix. If you multiply any matrix with identity matrix, then you will get the same matrix. If you multiply 1 with any number, you will get the same number. Same matrix. So definitely you can write A equal to I. A equal to I. Right? So here first question is 1 minus 1, 2, 3. First question is 1 minus 1, 2. 1 minus 1. We have to find the inverse of the matrix by using elementary operation. Otherwise I will write the question here. Find the by using elementary operation. Using elementary operation, find the inverse of the following. In this way they are in the question, in the text. What I am doing, I have divided the questions into 2 parts. 3 questions I will solve by using row operation. 3 questions I will solve by using column operation. In the examination, if they ask the question like this, no problem for the students. Why? Because elementary operation, which operation they did not mention in the question. You can do row operation, column operation. In the examination, if they ask column operation, I have to explain that also. So that's why 3 questions row, 3 questions column, I will explain. Right? So remember that we are going to solve the questions by using row operation in the beginning. First question is 1 minus 1, 2, 3. Right? 1 minus 1, 2, 3. No? 1 minus 1, 2. Right. What is the first step? First step. Listen very carefully. Method. Method is very important. We know that A equal to I. A equal to I. Right up? A. Capital A. What is capital A? 1 minus 1, 2, 3. What is I? 1, 0, 0. I means identity matrix. Keep this A as it is. Sir, you have written A. Sorry, what is A? Solution. Let A equal to the beginning. What is that? Let A equals to. Let A equals to. That's it. Solution I start here. That itself is question. Let A equals to. Now, sir, A means you have written here. Why you kept A as it is? At the end you will understand why we kept as it is. Okay? Right. A equal to I into E. Now, we are going to find the inverse of this matrix by using row operation. By using row operation we are finding. By using row operation we are finding. Right? Let's see. As per row operation, this one we have taken already. Now, as per the operation, 1001, 1001. As per the operation, this is here it is. This is first. This is second. This is third. This is fourth. Row operation means we have to bring the numbers 1001 in this way. We have to bring the numbers 1001 in that way. First concentration for this one, next concentration for this 0, next concentration for this one, next concentration for that 0. To get these numbers, which operations we have to do is the method. Right? Now, what is Roman letter 1? 1 is there. So, if you want to find the inverse of the given matrix, in the answer, this place should be 1. This place should be 1. Already 1 is there. So, no need to take tension. Already 1 is there. Oh, leave. Roman letter 1 already we got. Roman letter 2, 0. In this place, we want 0. In this place, in place of 2, we want 0. I already told you, just keep on listening. Once after completion of the final step, you will understand everything what I have done here. Till that time, you understand only the simplification part. After completion of the last step, then you will understand completely. Right? 100% I can give assurance. If you listen with the patience and interest, definitely you can understand clearly. Only thing is, without feeling sleepy, with a lot of interest, with a lot of patience, you just keep on listening. Definitely you can understand. Right? Okay. First thing is 1 we want. 1 is there already. Second Roman letter is 0 we want. At this place 0. At this place 0. Where we want 0? Here. Which place it is at this place? In which row it is? It is in second row. It is in second row. So, whatever the change we want, that is happening in second row. Nothing happened to first row. We are not changing anything in first row. So keep first row as it is. Nothing happened to first row. Keep first row as it is. We are changing second row. Sir, why are you changing the complete row? Change only this one. How can you change? Such type of rules are not there. If you want to change one number in second row, you have to change completely in second row. Okay? 3 by 4 fraction is there. You have to multiply both numerator and denominator with 2. Multiply both numerator and denominator with 3. Multiply both numerator and denominator with 4. Right? Is it possible to do like this? No. Is it possible to do like this? All of a sudden, there is one step 3 by 4 you got. In the next step, do you multiply like this all of a sudden? No. Same method here also. You cannot change only one element. You have to change the complete row. Otherwise, complete column. Right? Here we are doing row operation. That's why I am not discussing anything column. I am not discussing anything column. Right? I am discussing only rows. Only rows. Right? Now, this second Roman letter is in this place. This is in second row. Nothing happened to first row. That's why we kept the first row as it is. we are changing second row. Second row we are changing. How we are changing second row means second row. Second row. What are the elements in second row? What are the elements in second row? 2, 3, 0, 1. What are the elements in second row? 2, 3, 0. 2, 3, 0, 1. Right? R1. R1. What are the elements in first row? First row. 1 minus 1, 1, 0. 1 minus 1, 1, 0. Not visible? Just wait. Not visible? Just wait. 1 minus 1, 1, 0. Okay. Where we want the 0 at this place. At this place. Wherever 2 is there, at that place we want 0. Wherever 2 is there, at this place we want 0. 2 plus 1. 2 minus 1. 2 minus 2. So here we need 2. First row, here we need 2. Here we need 2 means we have to multiply this first row with 2. If you multiply first row with 2, then we get 2 here. 2 ones are 2. 2 into minus 1, minus 2. 2 into 1, 2. 2 into 0, 0. Now what we have to do? We have to subtract. Here this is plus 2, this is plus 2. Plus 2 plus 2 plus 4. We have to subtract. Subtraction means signs get changed. 2 minus 2, 0. 3 plus 2, 5. 0 minus 2, minus 2. 1 plus 0, 1 minus 0. Which row we are changing in second row? How we are changing? R2 minus 2R. R2 minus 2R. Which row we are changing? Second row. How we have changed like this? 0, 5 minus 2, 1. Right? Next. First Roman letter 1. Second Roman letter 0. Third Roman letter 1. It may be row operation or it may be column operation. If you want to get third Roman letter, it may be row operation or it may be column operation. If you want to get the third Roman letter, I am not speaking anything about first Roman letter. I am speaking about only third Roman letter, and this trick is applicable only for third Roman letter. Okay, once again, if you want to get 1 in place of third Roman letter, it may be row operation or column operation. If you want 1 in place of third Roman letter, whatever the number is there in this place, whatever the number is there, you have to multiply with its reciprocal. You have to multiply with its reciprocal. Here what we have? 5. What is the reciprocal for 5? 1 by 5. Multiply the complete row with 1 by 5. Multiply the complete row with 1 by 5. For example, in this place you have 7. We have to multiply with 1 by 7. Here 10 is there, 1 by 10. 9 is there, 1 by 9. Minus 3 is there, minus 1 by 3. Or 1 by minus 3, both are same. Okay? Minus 9 is there, minus 1 by 9. minus 11 is there, minus 1 by 11. Here for example 2 by 3 is there, 2 by 3. What is the reciprocal for 2 by 2? Multiplicate 3 by 2. Clear? So here R3, sorry, R2 we are changing R2, Roman letter 3 means this one. Where it is in second row. We are changing second row. How you are changing second row? We are multiplying the second row with 1 by 5. We are multiplying the second row with 1 by 5. We are changing second row. Nothing happened to first row. Nothing happened to first row. Keep the first row as it is. We are changing second row. How you are changing second row? Second row we are multiplying with 1 by 5. What are the elements in second row? Second row elements are 0, 5, minus 2, 1. We want 1 by 5 into R. 1 by 5 into 1 by 5 into 0, 1 by 5 into 5. 5 cancel 1. 1 by 5 into minus 2. 1 by 5 into 1. Right, it is right here. R2 we have changed it like this. 0, 1. 0, 1. Minus 2 by 5. 1 by 5. Okay now? Roman letter 1 we got already it is there. Roman letter 2 we got. Roman letter 3 we got. Roman letter 4. Where is Roman letter 4? At this place. At this place. At this place. Where it is? It is in first row. It is in first row. Nothing happened to second row. Keep the second row as it is. What is second row? 0, 1. Minus 2 by 5, 1 by 5. Nothing happened to first row. So nothing happened to second row. First row we are changing. First row we are changing. How we are changing first row? First row we are changing. First row we are. What are the elements in first row? 1 minus 1, 1, 0. What are the elements in second row? Second row 0, 1. 0, 1. Minus 2 by 5. Minus 2 by 5. 1 by 5. Okay. Where we want 0 in place of minus 1 we want 0. In place of minus 1 we want 0. Okay now? Minus 1 plus 1 0. So just adding both. Just adding both. Minus 1 plus 1 0. 1 plus 0 1. 1 minus 2 by 5. 1 minus 2 rough. 1 minus 2 by 5 LCM 5. 5 minus 2 3 by 5. 0 plus 1 by 1 by 5. That's it. So 1 0. 1 0. 3 by 5. 1 by 5. That's it. This is the inverse of the given matrix. Sometime back we have seen A into A inverse equal to A inverse into A equals to Y. We got this one. A inverse into A. Okay, we got this one. A inverse into A equal to Y. So what is the inverse of the matrix? This. Therefore, A inverse equals to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. That's it. Understood why we tried to get 1 here already is there. Why we tried to get 0 here. Why we tried to get 1 here. Why we tried to get 0 here. finally what we got here 1001. Actually 1001 was on right hand side. We got left hand side. Right? Given matrix into another matrix equal to identity matrix. That another matrix is identity. That another matrix is inverse of the given matrix. That another matrix is the inverse of the given matrix. If you have doubt, what you have to multiply this matrix and this matrix, then definitely you get this one. Definitely you get that. So that matrix looking very difficult, 3 by 5, 1 by 5, all our fractions are. Why do you take tension? Don't do like that, take 1 by 5 common. 1 by 5 common. 3, 1, minus 2, 1. Into here, what is in 1 minus 2, 3. 1 multiply. Keep 1 by 5, multiply. 3 ones are 3, plus 1 into 2, 3 plus 2, 5. Multiplication already over. First row, second row. 3 into minus 1, minus 3, plus 3, 0. Minus 2 into 1, minus 2. 1 into 2, minus 2 plus 2, 0. Minus 2 into minus 1, only 2. Plus 1 into 3, 3. Minus 2 into minus 1, 2. Plus 1 into 3, so it becomes 5. Multiply with 1 by 5. 1 by 5 into 5, 1, 0, 0. We got 1, 0, 0, 1. So this is the inverse of the given matrix. Right? This is the inverse of the given matrix. Okay? Same like that, just I am giving those who understood 100%, those people try the next question. I will give you the question. In the next class you try. But in the next class also, 2 questions I will teach on cooperation. 3 more questions I will go with column operation. Totally 3 questions from row, 3 questions from column operation. Remaining questions you have to try. Right? Okay. Thank you very much. See you in the next class.